All right, guys, let's get started. So guys, my name is Patrick. I'm one of the lead course creators at HadoopInRealWorld.com. Before I talk about today's webinar and before I give you guys an introduction about Hadoop in Real World, do me a very quick favor. Just type in your name, where are you from, and whether you're familiar with Hadoop in Real World or not. You know, if you're new to Hadoop in Real World, let us know. If you have already enrolled in any of our courses, please let us know. We would love to hear that. Thank you. You can just type your response in the chat. Karthik from Toronto. I'm aware of Hadoop in Real World. Leonard from Texas. Vikhil from Pune. Oh, we got a lot of people. ETL developer. Sonali from California. Mahesh from NJ. Someone is new to Hadoop in Real World. Okay, long time. We have Athenis, long-time student of Hadoop in Real World developer course. Srini from UK, great, welcome guys, welcome. Deepak from California, nice, nice, nice. Sanjay from India. Omaha, we have someone from Omaha, nice. I enrolled in Starter Kit, perfect. From Chennai, Ranjit from Chennai. Guys, welcome, welcome. Wow, there's so many people. We have Prashant from Dubai. Wow, that's great. Excellent. Gurdeep from Delhi, India. A lot of people from India, Florida. We have Srini from Florida. We have Venkat from Bangalore. We have people from Atlanta, familiar with your sites. Perfect, perfect. Guys, thank you so much for joining. Again, it's a Saturday, and with the daylight saving changes and all that, for some of you, it's actually 9:30 p.m., especially the guys dialing in from India. You know, it's 9:30 p.m. on a Saturday night. So guys, thank you, thank you, thank you. Thank you so much for joining, okay? So today's webinar is going to be very, 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 very interesting. We have participants who are new to Hadoop in Real World, so I'm going to give a very 2-minute or a 3-minute quick introduction about Hadoop in Real World, okay? So we are a group of big data consultants, and we started working in Hadoop and the other related technologies before Hadoop was this popular and cool, okay? So since then, we have implemented several big data solutions for many, many clients. All right, so we have worked with smaller clusters, but all the way to clusters with thousands of nodes. All right, so Hadoop in Real World was born out of real necessity, meaning when Hadoop was very, very new, and when we tried to hire people to work in our production clusters that we were managing, right? Since Hadoop was very new, you know, we couldn't, you know, it wasn't easy to get qualified candidates. So we would hire people, and then we would train them on Hadoop, right? So we would show them what we saw in our production environments, and basically we will ramp them up, right? So in few weeks' time, the engineers that we hired, or developers or administrators whom we hired, were ready to be on the job in few weeks' time, right? So whenever we go to a client and we are trying to set up a team, this is exactly what we do. You know, we hire people, we train them quickly, and then we'll push them out, right? So a few years after that, Hadoop became very popular. You know, big data tools like Hive, Spark, all that became very, very, very popular, right? So we packaged our training materials and courses into video format, and Hadoop in Real World was born, right? So we also did some comparison with other courses already out there, and quite honestly, we were very disappointed with what was already out there, because they were not talking about what should be covered for big data and Hadoop for real world scenarios, to handle real world production clusters. So that's exactly what we do, right? So 2015, you know, we launched our very first course. So 2.5 years later, we are happy because we have about 65,000 students from all over the world, you know, enrolled in our courses across all our courses combined, okay? So to know more about our courses, go to courses.hadoopinrealworld.com. So we have 4 courses in total now, and you know, a few other courses are in the works. Hadoop Starter Kit and Spark Starter Kit. The first 2 courses that you see here, they're actually free, so you can enroll it right now, right away, if you're interested in learning either Hadoop or Spark. And if you want to take your knowledge to the next level, you can also enroll in Hadoop Developer in Real World, Hadoop Administrator in Real World as well. You know, we have one course very specific for developers and one course very specific for people who are interested in administering Hadoop clusters. Okay. So I totally understand why you guys are here, especially for today's topic, because it's going to be an interesting and exciting topic. What we did was a couple of weeks ago, even in our last webinar, we said in our next webinar, we're going to cover some interesting interview questions. So we asked you guys, if you guys have ever been to a Hadoop interview, to send us your questions, and you did, right? So that we got several questions, and we are going to answer a lot of those questions. So these questions that we are answering today came from you guys, came from someone like you, right, who went to an interview, who sat in front of the interviewer, and he or she was asking the question, and you relayed the question back to us, right? These are the questions which you thought were challenging for you. All right, so let's get started with our very first question. And again, these questions came from you, okay? So the very first question is, explain your recent project, your roles and responsibilities, okay? Again, we have to ask these questions, right? As interviewers, you know, I interview other candidates myself when we are hiring for our clients, right? You have to ask this question no matter whether you are an experienced Hadoop developer or you're new to any kind of platform, right? So to get a feel for the candidate's work, you need to ask this question, explain your recent project roles and responsibilities. So even the experienced candidates, even people who are working in Hadoop for multiple years, struggle to answer this in a structured format, right? So they have everything on their head, you know, they just can't deliver it in a right, precise, concise way, okay? So that's why, you know, we are going to put a structure to this answer to the question, right? So there are three key elements you want to touch when you answer this question. The first thing is data ingestion, okay? So how are you getting your data into your Hadoop cluster, all right? So the second one is data transformation. Once the data is in your cluster, in your Hadoop cluster or your Spark cluster, what do you do with it? How do you transform the data? And finally, you have to say, once the data is ready, you know, to be analyzed or you know, to be seen, how do you show the data to your end users? Okay, so you need to touch on the tools as well when you talk about these three elements, right? So for example, for data ingestion, you can say, I'm getting my data from a database system. You know, I'm using Scoop for that. Or you're using Flume, or you're using Kafka, whatever it is, you have to say what kinds of tools you're using to bring the data into the cluster, right? And data transformation, are you using traditional Hadoop / MapReduce, or you're using Spark? You're running your jobs in a Spark cluster, or are you using writing Hive queries to transform your data? How are you transforming the data, right? Next is data visualization. That's the final part of it, right? Once the data is nicely massaged and transformed, how do you show the data to your end users? Do you use Tableau or Kibana or MicroStrategy or business objects, whatever it is, right? So you have to touch on all the elements to give the interviewer a clear understanding of what you actually do. Okay, so this will give the interviewer an idea, or it will also showcase, you know, your understanding of your project, right? If you're working on a real project, you're not going to work on every single element that is seen on the slide, right? You could be very much focused only on data ingestion, or you could be only focused on data transformation. You're probably writing Hive queries all the time for your end users, right? Then you have to say what exactly you do that, you know, fit your profile in these three elements. Okay, what is exactly you do? Do you work with Scoop all the time? Do you work with Flume to bring the data? Or do you work in Kafka clusters? Or do you work in writing Spark jobs? What do you actually do? Okay, so you have to touch on that. Next, you have to talk about your project, right? As a whole, you can't just say, okay, I write Hive queries day in and day out. That doesn't give anything to the interviewer. You know, you're not showcasing your skills right. Correct? So you have to walk the interviewer through what the project is all about, right? And where do you actually fit in? All right. So I'm going to give you a couple of examples from real projects that we worked in the past with other clients. Okay. I cannot name the clients, but I can give you the example or the layout of the projects. Okay. So we work for one of our financial clients, and believe it or not, some of the financial platforms that we have, they are legacy. Even though they are being maintained, they run on legacy infrastructure, so to speak. Okay. So in such systems, what they usually do is they get data from the exchanges, and the data gets accumulated over, throughout the day. When all the exchanges close, they run their batch processing. They call it end of day processing, right? Once the end of day processing is complete, they create files, mostly in an iSeries platform or a ZOS platform, whatever, right? So they create like flat files. Now these files are ready for consumption. So these files will be pushed to the downstream systems, right? So in our experience with one of the financial client, they had such a system, and they would put and every night the files will be ready. The files will be like few GBs in size, and they would push the files to our servers, to one of our to our Hadoop infrastructure. They just FTP it. It's pretty straightforward. You would think things would be more sexier than that, but they just FTP the file, right, to one of the nodes. And from there, we pick it up. We upload it to the Hadoop cluster, and then we run a few MapReduce job to aggregate the data. What we do is we take customers' activity, whatever they traded for that particular day, and we know what customers' positions are, meaning, for example, a customer can have 100 lots of Apple, right, or 100 lots of Tesla, whatever. That's their positions for the previous day. Now you take the current activity and you aggregate them together to show their up-to-date positions, on every single stock that they own, right? Now, once the data is aggregated, and this is the data transformation part, and what we did, we wrote like simple MapReduce jobs. Simple MapReduce job, once the data is loaded, we kick off the MapReduce job execute, and the data is loaded back to Hive, okay, behind Hive tables. Now our risk team comes in, and they didn't have any data visualization. They didn't really need any. They would query the data all day long for doing multiple risk-based analysis. Does the client have enough money to cover their positions if things go bad? Things like that. Do the client have enough money in their account to cover their positions when things go so bad in the market? Do they have enough collateral in the account to cover something were to go wrong? Things like that, right? So pretty standard stuff. Upstream system pushes the file to one of the nodes via FTP. We pick up the file, we upload the file. These are all done through scripts, right? A simple script. Hadoop fs dash copy to copy from local. You push it to the HDFS, and then you run MapReduce jobs. The data gets loaded to the Hive table, and you write Hive queries all day long on the data, right? And you can go, a little bit more sophisticated than that, right? What we just talked about is batch processing. You wait for the data, and then once the data is available, you process the data. But not always you do batch processing, right? So most of the time, most of the sophisticated systems these days, they are all stream processing. Your real-time data coming in, these are much more sophisticated, sexier systems that you would like to hear, right? For example, let's take Amazon, for instance, right? How are they managing their inventory, you think, right? Millions of people, go to Amazon, hit Amazon website every day, right? They shop on Amazon.com. So their inventory has to be up to date, right? They cannot wait for data to be aggregated towards the end of the day and push it to their inventory systems, right? So they have to keep up with the demand, and they have to manage their supply, right? So data gets pushed through Amazon website every single second. People buy from Amazon every single second, right? So they have to keep track of every single transaction and update their systems at real time. That's when stream processing comes in, right? So you, in that case, if your systems are delivering stream-based data or real-time traffic, real-time data, right? You would get those real-time events in a Kafka cluster, right? And Kafka cluster, can have like one producer producing all this data, and there could be multiple consumers. Maybe you load certain information into a database. Maybe you load certain information into your Spark cluster. And then you do transformation either in the database or in the Spark cluster, right? Or you could be loading your data into Hadoop via Kafka Connect or through Flume, right, to HDFS. And then you run your Hive programs on top of it, or Hive queries, or any query, Spark, QL, whatever it is, right? You run those on top of it. And then you can visualize the data in Tableau. These are real-time updates, right? These are real-time data coming in, getting transformed real-time in batches, right? As the data comes in, the data gets transformed. Whatever aggregation you want to do, you're doing either with Kafka streams or Spark streams or Spark streaming, whatever, right? So you're doing aggregation on the fly, and then you push the data to a platform where you can visualize the data. Now you're using visualization tools like Tableau, for instance, to look at the data in 3D charts, right? You can also have systems looking at this end result and trigger alerts. When the product goes down in inventory below a certain threshold, you can push alerts saying that we are running low. The demand is high, the supply is low. I have to refill my inventory, right? So you have to give specific examples. So to answer this question, first cover on these 3 elements, right? How does data come in? What kind of transformations you do? How do you visualize the data? Right? And then give a use case. Talk about your project. What is the use case for your project? How end users use your Hadoop environment or your big data environment and the tools. And then talk about how do you fit in? What do you do day to day? Do you work on data ingestion side? Do you work on Scoop? Or do you work on writing Hive queries or Spark jobs? What do you exactly do? And then touch on your expertise, right? So that's how you answer that question. Okay. So guys, I'm going to take questions at the very end. Someone actually asked, do we have a Q&A? Yes, we do a Q&A, but at the very end, so we don't disturb the flow of the presentation. Okay? Because we have a lot of questions to cover, guys. Yes. All right. So next. All right. These questions are related to MapReduce, right? So when we were preparing for this presentation, a lot of questions came in, and a lot of, we got repeated questions on MapReduce, right? Initially, we were not planning to touch MapReduce because we thought, okay, MapReduce is so basic, why touch on MapReduce, right? So let's ignore all the questions related to MapReduce. But then we saw a lot of people asking the same questions over and over and over again. Right? So that's when we thought, okay, even though things are basic with MapReduce, some people need help, right? And we have seen this in interviews too. People come in, we ask, we touch on certain topics, and then we have to go to the basic and ask about, okay, explain me, how MapReduce principle work, right? And they stumble. So we have seen this. So it's not new for us, right? So let's see these questions. Explain MapReduce flow in detail. Okay, so that's one question, right? The next question is, assume you have a 10 GB data set, how many mappers and reducers will be created when you execute a MapReduce job against this 10 GB data set? Another question. How does data get transferred from mappers to reducers? And the last question, if you have more than one reducer, how does data gets into the correct reducer? Right? So we got a lot of questions here. Okay. So we got a lot of questions here. We have 4 questions. Let's answer one by one, right? So before I do that, if you're watching the slide, I have either the faces in MapReduce. Again, for some of you, this is probably the easiest question, okay? But, when someone asks you what is MapReduce, you need to be able to explain this with good details, right? So in our courses in Hadoop Starter Kit or Hadoop Developer in Real World or any of our courses where we talk about MapReduce, we talk about we show this example, right? So assume you're trying to calculate the census. You're trying to see the population of a state like California, okay? And you wanted to see the population by city. For example, SFO, San Francisco, you want to see what the population is. For San Jose, you want to see what the population is. For Los Angeles, you want to see what the population is, right? By city, you want to see by city. And also you want to see by the whole state, right? So how do you do this? Let's talk about a traditional way of doing things. You send someone door to door, and then you knock the door, someone answers the door, you say like, how many people live in your home? And then you write it down, right? At the very end, when you have covered all the homes, you just add them together, simple, done, right? So now let's do the same thing in a distributed fashion so that we can finish the job much more faster, right? So, San Francisco is a big city, so you have to divide San Francisco into multiple small towns, right? And you send, one person to each town. So that's why we have San Francisco SFO1, SFO2. Same thing we have as San Jose 1 and San Jose 2, right? Same for Los Angeles 2. So you send one person to each divided small town, right? And you ask that person, when you knock on the door, all you have to do is, for the person who's in San Jose, you just write SFO, right? And then write the number of people. So the first home he knocks, right? There are 5 people in the home, so he will write SFO 5. On the second home, only 3 people, SFO 3. He'll write it SFO 3. Same thing for San Jose, right? He knocks on the door, someone answers, only 2 people living in the home, so he will write San Jose 2, right? So now you have to consolidate all this information, okay? So you send all the information that you have, that is, you have SFO 5, SFO 3, LA 3, LA 1, and all that to a centralized location, right? So a centralized location down, that is our headquarters. We have 2 headquarters now, California headquarters 1, California headquarters 2, and the person who's receiving all this information from different towns will aggregate the data together. Okay, we'll aggregate the data together by city. So for San Francisco, he will have the numbers. For LA, he will have the number. And for San Jose, he'll have the number. The important thing to watch here is when you're sending data to headquarters, all data for San Francisco should go to one headquarters, right? Only then you can aggregate the data. All right, so that's an important thing to note. Anything for San Jose should go to one headquarter, not both, right? You cannot split the data. You cannot send half of the data to headquarters 1 and half of the data to headquarters 2. You cannot do that because then you can't aggregate it. Then you need another layer of aggregation, which we want to avoid, right? Okay, so with MapReduce, let's talk about phases in MapReduce, right? So this is exactly what happens in MapReduce behind the scenes. Now let's put some technical jargons behind what we just saw, right? In the map phase, what we call mappers, you saw these small little humans right here. They are the mappers, okay? So they work against the small towns. We call them blocks. These are all data blocks, right? Data blocks on the disk on HDFS. So they basically read the data and they emit SFO 5, SFO 3. SFO here is a key, what we call key, and 5 is the value, right? It's a key value pair. So in Hadoop, it's always key value pairs, or with MapReduce, it's always key value pairs, right? Then comes the shuffle phase. So the mappers, they work on their own set of data, that is blocks in HDFS, right? And they emit key value pairs based on what they're processing, right? And then the shuffle phase is very important, because the shuffle phase says which key value pair goes where, okay? So it also makes sure all the key value pairs for a certain key, for a particular key, goes to the same reducer, okay? And in the reduce phase, you say 2 reducers in our example, right? CAH quarter 1 is reducer 1, and CAH quarter 2 is reducer 2. And reducer does its own logic to aggregate the data, okay? All right, so mappers work on blocks, right? They emit key value pairs. Shuffle phase is very important because it transfers the data from the mapper to the reducer. One important thing to note here is, the key value pairs of a key should go to the same reducer. So all the key value pairs for SFO should go to one reducer. It cannot be split between reducers. It cannot happen, okay? So the shuffle phase takes care of that. And reducers does its own logic to aggregate the data, okay? So now with what we know, let's go back and answer the questions, all right? So explain the MapReduce flow in detail. So we just saw that, right? Assume we have a 10 GB data set. How many mappers and how many reducers will be created? That's the question. Okay, so here we saw the mappers, right? And this is the block. So each mapper gets associated with the block, okay? So the number of mappers, it's very close, equals to the number of blocks behind the data set, right? So 10 GB divided by, if your block size is 128 MB, 10 GB divided by 128 MB. That's going to be your number of blocks, and that will also be most likely very close to be a number of mappers as well. Okay, so if you look at our MapReduce lesson in Hadoop Starter Kit, we'll talk about input splits, how the input splits is different when compared to blocks. You will see all that, So we don't have to go to that detail, but the number of mappers will be very closely equals to the number of blocks. Okay, so now let's go back. Number of reducers by default is 1 for a MapReduce job. You can, when you execute a job, when you start a job, you can say I want 2 reducers or 3 reducers. You can specify the number of reducers yourself. That's in your control. Okay, all right. Next question. How does data gets transferred from mappers to the reducers? That happens by the shuffle phase. As a programmer, or as a developer, as a user of the Hadoop framework, you don't have to do anything. Hadoop framework will take care of that for you. The data, once it's emitted from the mapper, will automatically get to the reducers. That happens through the shuffle phase, and it happens behind the scenes, right? You don't have to worry about it. Shuffle phase will take care of it. Next question. It's a very important question. If you have more than one reducer, how does the data get to the correct reducer? In our example, we have 2 reducers, reducer 1 and reducer 2, right? What the interviewer is asking here is, right, how does all the key value pairs for San Francisco ends up in HQ1 or reducer 1, right? How does all the key value pairs for San Jose ends up in reducer 2? That's exactly what the interviewer wants you to answer, right? How does it happen, right? In the shuffle phase, the key value pairs goes through a partitioner, right? The partitioner decides where the key value pair should go. A partitioner is nothing but a hash function, okay? By default, the partitioner that is used in the shuffle phase is called hash partitioner. A hash function is very simple, guys, okay? To a hash function, you supply a key, and then the hash function will give you a number in this case, right? So let's say you have 3 reducers, right? You put San Francisco into the hash function. You call the hash function with the argument San Francisco with your key, right? The hash function will emit reducer 1, okay? Anytime you send San Francisco as the input, it will say reducer 1. Anytime you say San Jose as the input, the hash function will say reducer 2. So for each key, the hash function will either say reducer 1, 2, or 3 if you have 3 reducers, right? And it's always deterministic, right? It's not a random association, right? So for a certain key, it's always a certain reducer. And it is decided by the partitioner that is used in the shuffle phase. And the default partitioner Hadoop uses is called a hash partitioner, which is nothing but a hash function. Okay, so the last question is a very important question. All right, okay. So we answered 4 questions in MapReduce. Again, if you want to go more deeper into the MapReduce concept, check out one of our MapReduce lessons or introduction to MapReduce lesson in the MapReduce chapter in one of our courses. Okay? All right. All right, so the next question, when to use Hive and when to use Spark? Okay, in this question, the interviewer is trying to understand, whether the candidate knows the difference between Hive and Spark, because it's, the difference is night and day between these two tools, right? Hive is a client tool, right? Hive is a client tool, and any type of queries you write against Hive will be executed as MapReduce jobs in a Hadoop cluster, okay? Whereas Spark, it's an execution framework in itself or by itself, right? Spark is a much bigger project than Hive. Hive is a client tool, whereas Spark is its own framework, right? It takes in your instructions, it forms a lineage, it forms a logical and a physical plan, and it executes the data against the data set, right? Most likely in a Hadoop environment, when you use Hive, you're using with Hadoop, right? And all your queries get translated into MapReduce job, which gets executed on a Hadoop cluster. Whereas in Spark, you can execute it against a Hadoop cluster, but that is not always, but Hadoop is not always needed with Spark, right? You can have a standalone Spark cluster. Spark cluster can stand on its own, right? You don't need a Hadoop cluster to run Spark jobs, okay? So Hive is a client tool, whereas Spark, it's its own execution framework. Got it? All right. Next question. Interesting one. Does Hive support ACID or CRUD? If you're seeing the question so far, we have not answered a question, what is Hadoop or what is big data? No one asks those questions, guys. We see online, right? Whenever whenever you type in a query, you can type in a query, say like big Hadoop interview questions or big data interview questions. You will find questions like, what is Hadoop? What are the 3 V's in Hadoop? No one asks those questions, really. Questions are going to be more technical like this, right? So what about this question? Does Hive support ACID or CRUD? Okay. One more thing about Hive, one more thing very important to understand about Hive is not a database. Even though you can run queries against Hive, it's not a database, right? ACID, what is ACID? For a transactional system like a database which supports transaction, ACID is the property that any database system should satisfy to make transactions work, right? What is CRUD? CRUD is nothing but 4 operations: create, read, update, and delete, right? These are database specific operation, right? What the question in simple terms is, does Hive support transactions, and does Hive support updates and deletes, right? Create, read, updates, and deletes. Of course, we know Hive supports read, but what about update and delete? And does Hive support transactions? Okay, very good question again, right? So now, to the answer. Hive support for ACID and CRUD, it's an experimental feature. It is available, but it's only available for a specific file format called ORC, okay, ORC, optimized RC file format, right? It is not available extensively for all other formats, okay? It's an experimental feature, although it is available, right? I think it's available after 0.13, Apache Hive 0.13, okay? So how does Hive support, if it's not a database, how does Hive support the, the ACID transactions? After 0.13 and also 0.14, there were several components added to Hive. For example, you can create a Hive table with ARC format and enable transaction support for that table. You don't have to make all the tables that you have in Hive to support transactions. No, you don't have to do that, right? You can have specific tables which can support transaction, and all other tables can be non-transactional. All right. So when you enable transactions, anything that goes inside the table, right? Anything that you insert or update, will be recorded in separate directories. Will be recorded in separate directories called deltas, right? And these directories, or these files under the delta directories, will be merged with the main files in a process called compaction. There are two types of compaction: minor compaction, major compaction, and it happens behind the scenes, right? For a user, you don't have to worry about this. Things happens behind the scenes, right? What you need to know is anytime you're trying to do an update or a delete, things get recorded in a separate set of files called the deltas, and these delta files are being merged to the main set of files, and Hive does this behind the scenes, right? It also has a transaction manager / lock manager. That's a class basically, which acts as an interface to support transactions. But all this, it is available, but it's available in a very crude format, okay? Because Hive is not a database, it is a client tool, right? It works against the data files in HDFS, that is it. Okay, so Hive is not a heavyweight database system like an Oracle or SQL Server or MySQL. Okay, so it is a client tool, but they have added the support, and they have added the support only for ARC file format. You want to know more about ARC? Go back to our YouTube channel, where you will find a video called RC file versus ARC. We did a webinar like a few weeks back on RC file versus ARC, so check out that video. Okay, so Hive does support ACID and CRUD in a very limited fashion, only with ARC file formats. Okay, all right. When to use partitions and when to use buckets in Hive. Okay, this is again another technical question. As you can see, we got a lot of questions for Hive, a lot of repeated questions even, actually. But of all the questions we got, Hive, for the tool Hive, we got a lot of questions, right? So when to use partitions and when to use buckets in Hive. So first of all, what is a partition, right? So if you have worked in the database side, in database systems like SQL Server or Oracle, partition is a very well-known concept for you. Okay, basically what you're saying is you're dividing the data, or you're partitioning the data horizontally, right? For example, you can decide to partition your table every day. So every day data comes in and it's stored in a separate partition. So for example, when I query for the data November 10th, my query will only look at the partition for November 10th. And why do we care about partitions? Because of its efficiency in performance, right? When your query only hits one partition, all you have to do is look at those records alone, and that is it, right? You look at those records and you're done, right? So your queries will be much more faster when you use partitions. All right. Similarly, just in like Oracle or SQL Server, you can create partitions in Hive. With Hive, a partition is nothing but a folder, right? When you create a partition, a folder gets created, and all the files will be stored for that partition under that folder. So when you write a query, your MapReduce, when you write a query with the var clause with that partition, for instance, again, we can say November 10th, right? So your query will only run against the files under that folder. So if you have a 1 terabyte data set, and if your partition size is only 200 MB, right, you're running your MapReduce job against the 200 MB data set. You can see the efficiency here, right? It's going to be very, very efficient. Okay, so what is buckets, right? Buckets is again another way of grouping data together, right? So you can create a table with, say, 5 buckets, and the bucketing column is, if we talk about, let's take stocks data set, okay? It's a data set with day-by-day information for different stock symbols for a particular exchange, New York Stock Exchange, NASDAQ, whatever, right? So you can create a table and you can say, I want this table to be stored in 5 buckets on the symbol column, right? So again, with bucketing, each symbol is assigned a bucket, Okay, again, a hash function comes in play here. So if you say like Apple, if the hash function says all records for Apple should go to bucket number 3, all records for Apple will go to bucket number 3. And if the hash function says all records for Tesla should go to bucket number 1, that's exactly what will happen at runtime, right? So the question here is, so both partition, as you can see, both partition and buckets are a way to organize your data, right? So when you run queries, your queries will only have to look at fewer files, thereby the execution is faster. Same with buckets too. Okay, so now when someone who asked this question, told us very specifically that the interviewer was very specific in wanting to know when do you use partitions and when do you use buckets. To matter of fact, he said he didn't care about the definitions for partitions and buckets. He wanted to know when should I go for partitions and when should I go for buckets. Okay, so he was very specific in his question, right? Partitions, it's used at the higher level. Okay, so for example, if you're trying to save all your records day by day in day-by-day partition, partition is the best fit for that, right? So you can store your data day by day. You can have a daily partition, right? Now let's say every day your data set is huge. Your data set is many terabytes, let's say, okay? Now in every partition you will have many GB of data. I'm just hypothetically, right? Each partition, let's say, has 2 GB file, right? Again, even after partitioning the data, your size is big, right? Your size is big. Now you're thinking about partitioning the data even more under each partition, which you can do, by the way, in Hive, right? You can partition the data even more. But most of the times when you try to do that, the more granular you go in partition, smaller the file size will become. Okay, so your leaf partition, that is the partitions at the very end of the folder, will have files with just fewer MB. If you know about Hadoop, Hadoop doesn't work very well with smaller files. It's not very efficient to process data in Hadoop with smaller files. Okay, so what do? You need a better way of organizing your data together, right? So that's where you can use bucketing. Okay, so with bucketing, you will say, organize my data into 5 buckets or 10 buckets. You can specify the number of buckets, right? With partitions, you can do that. And with partition, you can say, partition the data on this column. And at runtime, if that column has 100 values, you will end up with 100 partitions. Whereas with buckets, you can say, I want to get this table down to 10 buckets, right, on this specific column. So going back to our stocks data set example, if you say, under this partition, all my Apple records should end up in 1 bucket, that can happen, right? So all you have to say is, bucket my table with 5 buckets and use symbol as the bucketing column, right? So bucket can solve your small size issue when it comes to partitions, all right, because it's a defined number. You can define the number of buckets. The second advantage with buckets is with joining, it's with join queries, right? So Hive has a special type of join. When you try to join 2 queries together, right, you will write an inner join or a left outer join, right outer join, whatever join it is, right? With Hive, you can use, Hive can use a specialized join called sort merge bucket join on bucketed tables, which will give you better performance. So there are 2 main reasons I can think of. One is to avoid the small files issue. When you keep on partitioning your data, you can use buckets to alleviate that problem. And the second one is performance. When you do joins, you can use sort merge join. Okay, so that's the answer to that question. Cool. Okay, we spoke about join, and we got another question. What is map join and what is SMB join in Hive? Guys, I think we'll run overtime today, but that's okay. I'm having so much fun. As long as you guys are ready to hear, me talk this technical, I'm okay to speak, okay? What is map join and what is SMB join in Hive, okay? Guys, give me 1 second. All right. So what is map join and what is SMB join in Hive? So map join and SMB join is a specialized kind of join in Hive, which is focused on performance, right? So to understand what is a map join and what is an SMB join, you need to first understand how join works behind the scenes in Hive. Okay, a join happens between two or more tables, right? And you have a key to join on them. You can say, for example, in our example, we are saying we're joining two data sets. One is a stocks data set and another one is a dividends data set, right? A stocks data set can be huge. It could be in terabytes, whereas a dividends data set basically will have information if the stock ever gives out a dividend. And stocks, as you know, doesn't give out dividend like every day. It happens, every few months, right? So it's going to be a much smaller data set. All I want to see is I want to join the symbol and the date on stocks and dividends because both has symbol and date, okay? Very simple. That's my join query. So let's not talk about map join or let's not talk about SMB join. Let's talk about a very generic join and see how the join will work behind the scenes. And I don't have a slide for that here, by the way, okay? So when you're trying to join, the keys are used as the key that you use to join is very important, okay? Because in the shuffle phase, the keys that you're trying to use to join, for example, if you're joining by symbol, all the key value pairs or all the records with that key will go to the same reducer, okay? One of the table records will be loaded in memory in the reducer, and the records and the key value pairs for the other table will be streamed to the reducer, right? And the reducer will do a cross join in memory, all right? The reducer will do a cross join and will apply the equality or the inequality condition. Sorry, the equality condition, okay? Let's not talk about inequality now. The reducer will apply the equality condition and it will print out the result, okay? So one table, the records for one of the table will be sent to the reducer loaded in memory, and the other records is streamed through, and as the records are coming through, the reducer will do a cross and then apply the equality logic, to print out the result, right? So that's how a join works behind the scenes. Again, we go in so much detail in talking about the joins, map join, SMB join in our course. It's a separate lesson in itself, and I'm trying to fit this along with other questions in like an hour, So if you're feeling lost, don't worry, I'm going a little bit fast here, okay? So let's talk about map join. Why do we need map join in the first place, and what's wrong with our with the regular join, right? With the regular join, reducer is involved. Whenever reducer is involved, you're transferring data from mapper to the reducer, and you're sorting the data as well in the shuffle phase, okay? So when that happens, the performance takes a hit, right? And if you find a way, if you have an intelligent way to avoid reducer altogether, you can avoid the reduce phase and you can avoid the shuffle phase altogether, which means you'll complete the operation faster, right? So the 3 phases in MapReduce, and if you're completing your job in just one phase, that's a win, right? You're completing your job faster. So map join does exactly that. It does the entire join operation on the map phase itself, skipping the shuffle and the reducer phase altogether. Okay, skipping the reducer and the shuffle phase altogether. So let's see how it does that, okay? So I have dividends here. The very first thing it will do is, when you write a query like this, and you can see I'm adding a hint here that the query is on the right-hand side, right? Select star plus map join D. I'm saying D is nothing but dividends, right? Again, I'm joining stocks and dividends here. So when I say map join D, dividends will be pushed to what it is called a distributed cache. okay? And distributed, whatever elements you have in the distributed cache will be pushed down to each mapper, okay? And mapper, since it's local to the data, will read the stocks data set. It will read the dividends file from the distributed cache, and it will do a join. And the whole thing will be completed on the map face itself, on the mapper itself, okay? And that happens against all the mappers, right? Dividends get into distributed cache, and then dividends from the distributed cache is pushed to the mapper, and then mapper does the join operation by reading the stocks data set on the map side itself, right? So everything happens in the map side. You know, there is no shuffle, no reduce, okay? It's going to be much faster because you avoided 2 phases out of 3, right? So it's going to be much faster. One thing you need to keep in mind though, the dividends has to be small enough to fit in memory, okay? So you cannot have 2 big data sets and try to use a map join because you will result in out of memory. All right. So what is SMB join? I'm not going to go into SMB join into so much detail, but SMB join is again a specialized join which will execute in the map phase itself, skipping the shuffle and the reduce phase, but will only work on bucketed columns. It's called a sort merge bucketed join. Again, happens at the map side, right? But your table needs to be bucketed. That is, both tables or all tables involved in the join needs to be bucketed, okay? And there are a few more rules when it comes to SMB join, but I'm not going to go much deeper into that now, okay? Because we have a dedicated lesson for that in our courses. All right, when to use columnar format and when to use row format. Again, this question was covered in so much detail in the RC file versus ARC webinar, which is available on YouTube in our channel, right? So you can go to youtube.com/Hadoop In Real World and you can find that video right there, right? Basically, columnar format is very efficient when you're dealing with data aggregation because all the values for the single column is grouped together or stored together on the disk, right? Plus, columnar format is efficient when it comes to storing the data because you can apply efficient compression because your column values are stored together, right? So from the space standpoint and from efficiency standpoint, when it comes to data aggregation, you can go with columnar format. Whereas with row format, if you're doing a select star from tables all the time, you go with row format, right? Because your row, in a row format, the row, like all columns in the row, are stored next to each other on the disk. So if you're doing a lot of select star from queries, it's best to use row format, okay? But go check out RC file versus ARC video in YouTube. All right. What is the difference between RDD and DataFrame? This is a Spark question, okay? RDD and DataFrame. So whenever you write instructions in Spark, your instructions are transformed into RDDs, right? And Spark will form the association between the RDDs based on the instructions that you have created or written, right? And then those instructions are converted into logical plan and then to the physical plan, all right? And then Spark executes those instructions in the Spark cluster. Now, what is DataFrame? DataFrame is the next level evolution of RDD, right? You can say DataFrame is an improvement to RDD, all right? DataFrame gives you the ability to view RDDs with schemas, meaning as if you're looking at a table, right? You have columns in the table. That's what DataFrame is. You know, it gives you a way to look at RDDs with schema, with columns, right? So you can name a specific column and you can operate on it, right? There are a couple more important things when it comes to DataFrame. Okay, one is pluggable memory management, right? So you can basically use memory management frameworks like Project Tungsten along with Spark, right? So pluggable memory management and better optimizer, also known as Catalyst optimizer, right? So any instructions that you create, Spark takes those instructions, it creates logical and physical plan, and Spark will find out the best optimized way to run it, right? When you use DataFrame, you get much more efficiency with both pluggable memory management and better optimizer, right? But behind the scenes, even DataFrame uses RDD. Okay, it's all RDD under the hood. Okay, because RDD is a basic level of abstraction. But DataFrame will give you better handle on your data with schemas, because you can refer to your data just like you would refer to the columns in a table. Okay, so that's the difference. Okay, so we got some, there are a few more tools that people sent us in their questions. Basically, the interviewer was asking, what is the difference between Oozie versus Flume? What is Sentry? What is Kafka? Things like that, right? I'm going to touch on these tools on a very high level, very briefly, all right? Oozie is a scheduler tool, right? Meaning you can have like multiple MapReduce jobs, that is executed on a cluster, right? But there could be dependency between the MapReduce jobs, right? Maybe you want to run MapReduce job number 1 first, and once it is done, you want to run MapReduce job number 2. And maybe once MapReduce job number 2 completes, you want to run a Hive query. You can form the workflow with a tool like Oozie. So it's basically a workflow management tool for Hadoop, right? When you have many MapReduce jobs, you can basically even define the dependency. You can say, run these 2 MapReduce jobs, and once they both are complete, run the 3rd MapReduce job and send me an email once it is successful. You can say that. You can define a workflow with Oozie, right? Flume and Kafka, they are data ingestion tools, okay? Meaning they bring data into your cluster. These tools help bring data into your cluster. Flume, for instance, can ship log data from multiple servers to HDFS. Okay. Kafka, on the other hand, Kafka is a cluster on its own. It has it's a distributed cluster, meaning multiple nodes, right? And Kafka will be used in real-time streaming applications, where every second you're getting thousands or hundreds of thousands or even millions of events coming in to the Kafka cluster. There could be multiple producers producing these events, and there could be multiple consumers consuming the events from Kafka, right? It's a distributed environment, so you don't have to worry about scaling your environment. That's a nice thing about Kafka, right? Maybe now you have, like 1,000 messages coming every minute, right? But what if you want to scale? What if you're going to get 1 million messages a minute, right? You can scale, you can horizontally scale with Kafka. You can add more nodes and you can scale horizontally, right? You can push messages from Kafka into HDFS, to your Spark cluster, and to many other places. Okay, so Kafka is used in real-time streaming application, right? What is Sentry, right? Sentry is an authorization tool, right? So when it comes to Hadoop, who manages the security, right? So, we have our desktop and laptop, right? We can give our user ID and password, but how security is managed in Hadoop, right? So with Hadoop, authentication is managed primarily by Kerberos, right? So you use Kerberos for authentication in Hadoop, right? That basically says, authenticate this user ID, password, ticket combination, private key, public key, that kind of stuff, right? So you're logging into a system. That's authentication. Once you're authenticated into your system, what prevents the user from not seeing someone else's data, right? So that is authorization. What the user is authorized to see inside Hadoop, right? So Sentry is a tool for enforcing authorizations in your cluster, right? So it can work with certain tools. So you have Sentry server, right? And you can have Sentry plugin that can be installed with compatible tools, like for instance Hive, right? So you will install Sentry plugin on your Hive. So anytime when user executes a query, before Hive produces the data, it goes through Sentry. Sentry will say, okay, this user is trying to use this table, and this user doesn't have access to the files behind this table. So it will tell Hive, don't run the query. I'm going to block the user right here. So that's what Sentry does. Okay, so it's for enforcing authorizations. All right. Okay. How do you promote code to production? So that's a good question, and I'm sure this question was asked to an administrator, right? Or someone who went to an interview for an administrator position, right? How do you promote code to production? We talked about Uzi just a little while ago, right? So most often than not, Uzi is used in production. However, we have seen several flavors of deployment strategies that's used in production, right? Some companies, they don't use tools like Uzi to manage their jobs. They have like fewer jobs. So, we have seen like simple scripts running the jobs on a specific time. It is okay for them. They wanted to keep it low because, they have only fewer jobs to maintain. When you have a lot of jobs and when your jobs have multiple dependencies, you want tools like Uzi to help you with production deployments or to manage your production, right? And who deploys code to production? I'm sure the interviewer also wants to know who deploys code to production, right? So usually your jobs or your Hive queries are executed on a node outside of your Hadoop cluster. It's called an edge node, right? And even users using the Hadoop cluster will have access to the edge node as well, right? There could be a collection of edge nodes too, right? In one of the edge nodes, you will be running the jobs that are supposed to run on a regular basis, right? And only few users will have access to that edge node. So when you ask, the few teams could be your administrator could have access to the edge node, or may only have access to the edge node, or it could be your operation staff, right, who's responsible to manage the health of the cluster, or maybe only they have access to the edge node. So you need to produce instructions along with your test results, test evidence, and all that. It depends on what kind of code management that you use in the company. You would have to maybe raise a ticket or whatever to push, along with instructions. You need to ask the corresponding team to either use Uzi or to run a script to invoke the job. Okay. All right. So that's it. It depends. It totally depends. There's no straightforward answer to this. Each company does it differently. Some uses plain scripts. Some uses tools like Uzi, or I've seen clients using Azkaban. It's a tool from LinkedIn. LinkedIn has a lot of Hadoop jobs, so they use tools like Azkaban to manage their Hadoop jobs. It's an open source project, so I've seen other clients use it as well. Okay, but access to the edge node is protected. Only few people has access to the nodes to promote or to run anything on the edge node. But there could be other edge nodes where it's meant to be used by the end users of Hadoop, like for data analysts or data engineers or whatever, right? Usually, users are not allowed to log in directly to one of the nodes in the cluster because that would be chaotic, like you need to create different user permissions and all that. That would be unmanageable. So usually your Hadoop cluster is intact. Only administrators can log in to those nodes, and you have like few edge nodes outside the Hadoop cluster but has access to the cluster, from where you can execute jobs into your Hadoop cluster. Okay. All right. Now, before I go any further, guys, I want to take some questions. I've been talking for so long, I feel. What about questions, guys? Any questions? You guys have any questions for me? Yeah, you can type in your questions, please. Yep. Okay, so I got a few questions here, which is asking how many environments will be there in a Hadoop project? Okay. At the very least, you would have 3 environments, your dev, your test, and your production environment, at the very least. The environments may not be the same size. Okay, so your dev environment will be much more smaller, right? Your test environment will be slightly bigger when compared to your dev environment. If you have a pre-prod or a UAT environment, it will mirror to the same configuration as your production environment. Okay. Will the dev environment has edge nodes? It depends. I have seen places where dev environment also has edge nodes, especially when you have teams in multiple regions connecting to a Hadoop, a unified Hadoop cluster. You will have edge nodes in that scenario. But if it's a very local team, they usually have access to the dev environment. Okay. What is the difference between Scoop and Flume? Scoop is primarily to bring the data from your RDBMS, right, or your database, like SQL Server or Oracle. With Scoop, you can actually create jobs that can run every day to bring the data from your relational database into Hadoop or HDFS or to Hive tables. Flume is a little bit different. Flume can work with other tools as well. For example, Flume can actually work with Kafka to bring the data from Kafka into HDFS. Flume can work with other nodes to basically extract information from other nodes and push to HDFS. They both are data ingestion tools, but Scoop is very specific to database. Can you talk differences in Parquet versus Arc? Okay, so Parquet, we have covered Parquet in our courses as well. Hierarchical data work very well with Parquet. Okay, the asset support is not added to Parquet yet. So if you're using Cloudera distribution, you won't get direct support to use asset with Parquet because it's not supported, right? Whereas if you're using Arc, it is supported. All right, it's more of an experimental feature. It was started with Arc. But I'm not sure whether there is any Jira out there which someone is working on implementing ACID with Parquet. We're not aware of it. Why Hadoop is slow even with a key value pair? Define slow, right? Slow is a relative term. If you're comparing Hadoop with Spark, yes, you can feel Hadoop is slower. The key value pair is there to support the shuffle functionality and to bring the data together in a distributed environment. That's why the key value pair exists. That's why the model is based on key value pairs, right? When you want to group data, when you want to pull data from different systems and aggregate to one or few nodes, you need a way to aggregate it. That's why key value pairs exist. But Hadoop is a batch processing system, right? So it's not a real-time based system. Yeah. Why are you using Hadoop and why not Z? Why not XYZ? Okay, I mean, again, what is XYZ, right? It could be, someone could be asking, why are you using Hadoop and not Spark, right? Spark, first of all, Spark is relatively new compared to Hadoop. Maybe you started with Hadoop and you're looking at jobs where you can even more optimize with Spark. That could be a good answer. It is, for example, someone can ask, why are you using a text file rather than using Arc, right? That's actually a very good question, because with file formats like Arc or Parquet, you're going to get much more performance benefit out of it, For that, you can say, if you're not familiar with Arc or Parquet, I would say make yourself familiar with Arc or Parquet before you go to an interview. And you can say, yes, we are looking into using Arc or Parquet, something like that. You don't use it, but you can say, yes, we are looking into it. We are comparing, we are doing some benchmarks between, dev environment to prove out that it's going to be much better. Yeah. In the long term, Hadoop is going to go away or stay. Well, Hadoop is going to be around for a long time because there are a lot of tools in the ecosystem that is using Hadoop. Although the technology will get more mature, you will be seeing a lot more people using, will be running Spark on Hadoop and things like that. And even the tools mature, we have integration with Hive and Spark. Hive was only supposed to work, or not supposed to work, but Hive was designed to work on Hadoop. Now, it can work with other tools too. So that's the beauty of the open source framework, right? As the ecosystem evolves, the tool will also continue to evolve. And you should also keep in mind that Hadoop is being used in a lot of companies when compared to like 3 or 4 years ago. But there are still a lot of companies still exploring. They're still they still want to get into the technology, but not know how, and they think they don't have a use case right now. So we are getting a lot of data every day. Our data consumption is growing a lot, right? So there will be big data technologies, and Hadoop will continue to evolve along with the other tools in the ecosystem. Yeah. Okay. Let me see. Wow, I got many questions here, guys. Maybe we have to collect all these questions and do another part 2 interview questions. I think maybe we'll look into that. Why default always one reducer? That's just the default. You can always change it. Basically, the user who's writing the application knows the application better, knows the use case of the application better, and knows the data that you're trying to process better, right? So if you feel you need more reducers to distribute the load or to finish the job sooner, you have to look into having multiple reducers. What kind of memory issues we expect when you're streaming data using Spark and Kafka? Okay, yeah, I mean, we can cover that, excellent. All right, so guys, I'm not done with questions yet. I have two more very good questions, right? 2 more very good questions yet to cover. Actually, I left it at the very last because we ask a lot of questions in interviews, and when I saw those 2 questions, I was like, wow, those questions has to go in my list of questions to ask in my interviews, okay? So those were very good, but I wanted to quickly talk about the courses and the discount that I was talking about, okay? So as you can see, the Hadoop interviews or big data interviews can get very technical, right? Because there are no questions like what is Hadoop or what is big data, explain me the 3 V's that you see in other websites. No one asks those questions, and no one should ask those questions. Those are not even basic, right? So when you go to Hadoop interviews, you're going to get hit with some real world scenarios, and you're expected to know how to handle those real world problems and real world questions, right? So you need to have answers to those questions. So in our courses, right from the beginning, when we start designing the courses, that's exactly what we did, right? So our courses are structured a little differently when you compare it with others. We focus on what is needed for the real-time aspects. That's why we put more emphasis on file formats. We put more emphasis on troubleshooting and optimization. We put more emphasis on cluster management or planning, schedulers like capacity scheduler, fare scheduler, and things like that, right? So because we want you to understand how things work in the real world, not just like concepts. Who cares about concepts, right? You want to know how you can work things out in the real world, right? You need to know the concept, sure, but you need to know how to go beyond the concepts and look at things, right? That's exactly what we do in our courses. In fact, we cover a lot of interview questions, in the lessons itself, right? So when we talk about concepts, when we do demonstration, we talk about interview questions too, and we talk about production scenarios where we have seen issues ourselves, dealing with specific tools or specific functionalities, right? So that is exactly what our focus are. And quite honestly, when we received a lot of these questions, we were happy to see that we have covered almost everything in our courses. So, we feel very confident from that aspect, right? Because when we got questions coming in, there were a couple of questions that we didn't touch, but 99% of the questions we have covered in our courses, and we felt very confident and comfortable to see that actually, right? And all our courses, we have step-by-step lessons, real-world scenarios. You get free cluster access when you enroll in our courses, right? So you can try out Hadoop right away. You don't need like virtual, like a virtual node or virtual machines or a sandbox environment. No, you will have access to a 3-node Hadoop cluster hosted on AWS cloud, and we'll give you the access right away. Next, you have lifetime access to both course and the cluster, right? So you have lifetime access to the courses, and we do update our courses regularly. Someone was asking about Kafka. Kafka is coming out end of this month, and it will be added to the Hadoop Developer and Real World courses. So anytime we come out with an update, you will get it automatically. So you get lifetime access to our courses, lifetime access to all the upgrades that we do. Hadoop or big data is an evolving environment, right? So, things come out almost like every week in the Hadoop ecosystem. So we have to keep our courses up to date, and we do. Okay, so we do keep our courses up to date, and you will get everything, every single update that is done to our courses. Okay, so I said I have a couple more questions, and I wasn't lying. And these questions were very good because I'm going to use these questions when I do interviews next time, okay? All right, so why odd number of nodes, 1, 3, 5 in a cluster? Okay, so why do we need odd number of nodes, 1, 3, 5 in our cluster? Let me define the question, okay? There is no requirement in Hadoop, in a Hadoop cluster or a Spark cluster, that you should have the number of nodes in odd numbers, right? So there is no such requirement. All right. So what is this question about? Actually, this is a very important question. So they have to mean something here, right? So there are some specialized clusters, like for example, Zookeeper, where the cluster or the service provided by the clusters is deemed available only when majority of nodes in the cluster are up and running. When majority of the nodes in the cluster are working, only when, right, the service is deemed available. Okay, so now let's talk about this. Let's say you have a Zookeeper cluster, all right? And let's say you have a 3-node Zookeeper cluster. One of the node goes down in your Zookeeper cluster. You have 2 remaining nodes, right? You still have majority of your nodes in the cluster up, 2 and 3 is the majority, right? You still have majority of the nodes up and running. So even though one of the nodes go down in your 3-node cluster, Zookeeper cluster, your cluster is still active and live, okay? Because your majority of the nodes, in your case, it's 2, they're up. If another node goes down, now you lost the majority, you lost the majority, right? So your cluster becomes unavailable at that point, right? Now let's talk about 4 nodes in a Zookeeper cluster, okay? An even number, 4 nodes in your Zookeeper cluster. One of the node goes down, you have 3 nodes, your cluster is still available, right? Because still you got majority of the nodes up and running. 3 nodes in a 4-node cluster running. You have the majority up and running, so the cluster is available. But let's say another node goes down, you have only 2 nodes, right? You have only 2 nodes in your cluster, you lost the majority, right? You lost the majority, it's a split, 2 versus 2, 2 up, 2 down, right? So your cluster is down in that case, right? So in a 3-node cluster, you can tolerate 1 node failure and still be available, right? In a 4-node cluster, you can tolerate 1 node failure, you're available. If 2 node goes down, right, your cluster is not available. Just because you got a 1 node extra with your 4-node cluster, you can still tolerate only one node failure, okay? Because as soon as you lost the 2nd node, you lost the majority, right? So for Zookeeper, majority is very important, right? So that is the reason. So when you compare 3 versus 4, both can tolerate only one node being down to be functional. So it's better to run a 3-node cluster than a 4-node cluster. Makes sense, right? So that's why, it's insisted to have, odd number of nodes in your cluster. So 3 nodes and 4 nodes can tolerate only one node failure each. So why bother having one extra node when you can achieve the same functionality with 3? Yeah, so that's a very important question actually, a very interesting question. Next question, is it possible to make a mapper multi-threaded? Ooh, that's a good question too. By default, mappers are single-threaded process, okay? Mapper are single-threaded process. You can have multiple mappers, okay? So you can have multiple mappers running, running against your data set, but within the mapper, it's a single-threaded process. It's not thread safe. You cannot run multiple threads in the mapper because it is not thread safe, okay? But there are other implementations with which you can make your mapper run as multi-threaded, okay? So you need to use a special implementation or a subclass called multi-threaded mapper, right? You need to use a special extended class called multi-threaded mapper, and then you need to set your mapper class to your job along with multi-threaded mapper. And then you can define the number of threads, right? We're going to write a blog post in the future on this topic, so I don't want to show you code and things like that here. But it is possible to do so with multi-threaded mapper class, okay? So why would you do this? Most often you don't need to do it, but if you have like CPU bound jobs, you can think about doing this. But it is always better to have multiple mappers running, right? It's a bad idea to implement something like this thinking that you're going to reduce the number of mappers that you're going to run. That's a bad idea, okay? That's a bad idea and you shouldn't do it. So it is possible, but we're going to write a blog post on that topic, okay? There was another question which someone asked, which is not here. It just came to my mind and I wanted to cover it. How do you tweak the resources for a job that is in execution? Let's say you don't have enough resources for a MapReduce job. You got like 3 reducers running for a job, right? And it's not finding enough resources. How do you do it? At runtime, what can you do to help the job complete? That's where scheduler comes in play, right? Topics like fair scheduler and capacity scheduler comes in play, where you can extend or contract the amount of resources that is allocated for a job, okay? And it can be done at runtime. You can say, now I'm going to expand the amount of resources available for this particular queue. Okay, so you can expand the memory. So suddenly the job will have resources to run once you expand the memory, and it can be done at runtime, right? It can be done. You don't need to do any restarts for those, right? So that's how you do that. That's a very good question too. That's a very good question too. All right, guys. Any other questions that you might have? I think this is probably the longest webinar that we did. It was a very good webinar and got many questions answered. Thank you, thank you, thank you. All right, guys, it was a blast doing this webinar. I think this was the most fun we had in a while doing webinars. It was a lengthy session, but we had so much fun. Guys, thank you so much for joining us. And if you have any more questions, any more interview questions, we can even do another part of this webinar, okay? So do send us your question over info@hadoopinrealworld.com. Definitely send your questions over. Okay, guys, thank you for joining and see you next time.